I'm Jennifer Wickleman, and I'm going to be doing this Math 117 Test 5 review. Your guys' final is next week, and I'm going to be having a review on Thursday and Friday of this week on Thursday at 11 o'clock and Friday at 2 o'clock, so please feel free to stop by lower level of the library and get that final exam review in under your belts. This is going to be the test review for this test that most of you have tomorrow, so I'm going to be going over this so that you guys can get some understanding of what's going on here, okay? Well, let's first talk about this and starting out with section A1 and A2. It says use the following graph, use the following graph to answer questions 1 through 3. They're telling you that this shaded region corresponds to this type of alpha. We really don't need that information because they tell us what our z-score is there. So then the next one is that they're asking, which is, you can't really see, negative 1.96. So here's the deal. If your test value that you're testing falls anywhere in this range, meaning that it's less than negative 1.96, you're going to reject it because it is in this danger zone of things that would mean that you would reject it. If it was anywhere else, if it was over here in all this white space, we would not reject it, okay? So looking here, I'm comparing negative 2.32 to negative 196. Does this fall into the danger zone? Yes. Because it does, it should be rejected, okay? The next one gives me negative 1.95, which is just slightly less. It's right there, okay? Which means it's not in the danger zone, which means we are not going to reject it, okay? Now it asks, is this a left-tailed, right-tailed, or two-tailed test? This is a left-tailed. As you look at this graph, you see that it is the left side, okay? A right-tailed would obviously be shaded over here. And a two-tailed is whenever you have both of them. That's what the tails mean. Now let's go on to the next question. The next question is asking us to state the null and alternative hypotheses for each of these. Okay? You have several different types of hypotheses whenever you do it. If we read this one, it says the average number of runs scored per game is this. They don't say anything else, like greater than, less than. So in that case, your hypotheses, the first one is always going to be h naught mu is equal to whatever this number is. Okay? So it's just mu is equal to 4.71. My alternative, h1, okay, is that mu does not equal. Why is it does not equal? Well, they don't say greater than or less than. So in the case where they don't say greater than or less than, you are going to use the do not equal. Now look at the second question here. It says the average cost of living is greater than. So whenever I do this one, my h naught, again, it's always equal to, okay? My alternative is going to be greater than. Exactly like that, okay? And that's just what you do for those. Now the next one is telling us to use the graph to answer these questions. In your book, on page 409, they have a nice little chart that kind of helps you out where you have certain alphas, or they give you the, z values here, and you figure out what is your alpha, what's going on. They break that down. Another way to do it is on your T chart in the back of the book, table F, I think it is. I don't have the book in front of me, but it's where they have the T values. At the top, they talk about one-tailed and two-tailed tests. They have the alphas, and at the very bottom, they have the z-scores. So that's where you want to be looking if you don't have access to page 409 of your book. Now, this is asking for a two-tailed test pictured here. They tell you the critical values. So you need to figure out which alpha corresponds to a two-tailed 1.96 critical value. If you look at the chart in the back, you'll find out that it would be this 0.05 alpha. If you look at the chart on page 409, you would also see that it's a 0.05 alpha. Okay? Number 7 says, if you were given a problem with a mean of 20, what would the hypotheses be? Well, look here. This is a two-tailed graph. So if it's a two-tailed, it's going to be a equal and do not equal. Equal and do not equal are always the two-tailed graphs. Where it says one is equal and one is greater than, the greater than is going to be a right-tailed graph. And when it says equal to and less than, then that's going to be a left-tailed graph. Okay? Those are your three possibilities. So this one would be h naught, mu is equal to 20, h alternative, mu does not equal 20. Boom. Next one says, in the event that you computed a test value of negative 1.43, the null hypothesis would be what? Well, negative 1.43, here's negative 1.96, right? Negative 1.43 is like somewhere here. Not in the danger zone. So we don't reject it, okay? It's not in the danger zone. The next one says, let's say you got a test value of this big old number. Well, guess what? That's definitely in the danger zone here on that side. If it's on either one of those danger zones, you're rejecting that guy, okay? Reject him like some guy on the street hollering at you. All right, let's look at the next set of questions. The next set says, for an alpha 0.01, find the critical value given that the test is right-tailed. So you know that's one of these. Again, you have to look at the chart in your book. You need to go to that T-chart. You need to find where it says one-tailed, and then you got the 2. I don't know what the order is. You find the 1, you find the 0.01 alpha, you go all the way down to the z's, and then that's going to give you the z-score right there of this guy, 2.326, okay? Now, if I'm comparing a value of 2.14 to 2.36, here's my 2.326. 2.14 is falling over here, so I'm not rejecting it, okay? Okay, let's do this example. All right, let's actually have us do this. Now, for each of these, we need to state some things about these whenever we do them. So we have to do our hypotheses, we have to do the critical values, we have to compute the test value, make a decision, and summarize the results. Hey, here's the deal. I'm not really going to summarize the results. I'll tell you, but I'm not going to write it. It's just a sentence that says the exact same thing, whether you reject or do not reject. So it says, we'll come along to it in the example. I'm not going to tell you now. So, okay, let's do the problem. So, they tell me the average moviegoer sees this many movies a year. That's starting out right away. My H0, mu is equal to 8.5. I know it. Random sample of 40 people, large university, realized the average number was 9.6. Population, alpha 0.05. Can this be concluded that it represents a difference? That tells me it's a two-tailed, right off the bat. Two-tailed test. Doesn't say greater than or less than, okay? So H1 mu does not equal 8.5. Now, I use my alpha, a 0.05, and I know it's a two-tailed. So I look and see what are my critical values. My critical values are the plus minus 1.96, okay? Now I need to compute my test value. Hey, it's the very nice, familiar old Z formula that we are just so awesome with at this point. All right, we're used to seeing that. They give us all the information in the problem. X is my test value, is my 9.6. My X bar is my 8.5. They give me sigma, which is 3.2, over the square root of 40. I punch all that in the calculator, and end with 2.17. Well, let's compare 2.17 to 1.96. It's falling in the danger zone. If you're not sure, do your little thing. Here's 1.96. You'll see that 2.17 is definitely in that shaded danger zone. So we reject H0. Now, this whole summarizing thing, what you would say is that there's enough data to show that there's a difference from the national average. Something like that, a one-sentence little, there's enough evidence or there's not enough evidence to show. That's all you got to say, okay? But I'm not writing that out because I'm lazy. Let's look at the next one. Now, same type of problem. We need to figure out what are we doing. So read through here. We see that there's a random sample of 32 infants. We see that there's an average of 30.9. That's my, right off the bat, I can figure out this is this, okay? I can figure out my alternative. Goes through the problem, I see alpha is 0.01. I see greater than. Greater than tells me it's a one-tailed, it's a right-tailed. So greater than 30.9. I know it's right-tailed. Okay? And I know that my alpha is 0.01, so at an alpha of 0.01, I look in the back and I find my critical value. My critical value is going to be a positive 2.33. Okay? Because, why is it a positive? Because it's a right-tailed test where the positive numbers are. I should know this by now. So this is 2.33. Anything bigger than that is in the danger zone. Let's go ahead and do our computing part. Same formula as the last problem. So Z is equal to 32.1, my test value. sorry, my test one that they're claiming here, minus 30.9 all over 3.6, square root of 32. Punch that in the calculator, I get 1.89. Whoops! Sorry, that's over there. So we do not reject. And if I had to summarize, I would say that there is not enough evidence to show that these to conclude that the mean is greater than the national mean. Something along those lines. All right, now I'm going to stop here and I'm going to start up with